Hey everybody, this is Mrs. Masteller again. Now we are starting chapter 10, which is arithmetic sequences. So starting with this, so pretty short chapter in its entirety too. So we're just doing arithmetic sequences, arithmetic series, geometric sequences, and then geometric series. So starting with our definitions, what is a sequence? A sequence is just an ordered set of numbers, often forming some type of pattern. So a sequence is an ordered set of numbers, again, often forming a pattern. So there's some type of pattern happening with these numbers, and that's kind of your job to figure out, well, what is the pattern. Okay, each term is basically, or a term is just going to be each individual number in the sequence. So this is just going to be a number in the sequence. So every individual number that you see is just called a term. But specifically, again, today we're talking about an arithmetic sequence. So what is an arithmetic sequence? It's just when you're adding or subtracting by some common number to get to each and every single term in the sequence. So it's just going to be adding or subtracting by some common value. Okay, so you're adding or subtracting by some common number each and every time to get to every single number you see in the sequence. And the number that you're adding or subtracting by is called the common difference. So this is just the actual number you are adding or subtracting by. And that's the common difference. So we also have this cool formula we're going to be using all throughout this section. So it's over here in the upper right-hand corner of your notes. So it says a sub n is equal to a sub 1 plus n minus 1 times d. So I just kind of want to break down what do each of these actually represent. So just from left to right, what is a sub n in this formula? A sub n can be kind of one of a few things. A sub n could be the last term of a sequence, or it could be a specific term that you want to find. So for example, if I had a sequence and I asked you to find, the 35th term of the sequence, then I'm basically asking you to find a sub 30n. Okay, so it could be a specific term that we want to find, or it could be also the last term of the sequence altogether. A sub 1, the next thing you see in the formula, that's kind of easy. It's always going to be the first term. So the first term of the sequence is going to be a sub 1. The next one is n. Again, that can play a couple different roles. It could be the total number of terms, or it could be a specific term number. So as I already mentioned, if I asked you to find the 35th term of a sequence, then that would mean that n is 35. That's going to be my specific term number that we're trying to find. And we already know what d is. D has already been described in the definitions, but that's just going to be the common difference. That's what d represents. And again, that's just going to be the number you're adding or subtracting by. Okay? So let's put this all to good use. Here we go. So these examples, it says to find the next four terms in each arithmetic sequence and also the common difference. So first figure out the pattern, basically. So looking at these numbers, if I'm starting with -8, then I go to -6, and then to -4, what are we doing each time? Well, the common difference is that you're just adding 2. Okay, I'm increasing by 2 every single time. So that's my common difference. Now find the next four terms. So if you keep doing this pattern, after -4, you would have -2, and then 0, and then 2, and then 4. Okay, and that's it. That's all you have to do. So number 2, same idea. Figure out what are we doing each time? What's the pattern? Well, we're adding 4 each time, so d would be +4. And now just keep adding 4, so you'd have 19, 23, 27, and then 31. Okay, the next one, again, find the pattern. Looks like it's increasing by +5 this time. So adding 5 to the next number, so from 32, now I'm at 37, and then 42, and then 47, and then 52. The next one, find the common difference. So once again, if you look at these numbers, they're increasing, looks like by 5 again. So then we have 5, 10, 15, and then 20. The next one, our numbers are actually going down. They're decreasing from 15 to 7 to -1. And they're decreasing by 8. So you can either say that you're adding -8 or that you're subtracting 8, same thing either way. So if I just keep adding -8 or subtracting 8 from -1, I'd have -9. and then negative 17, and then negative 25, and then negative 33. Okay, and the next one, numbers are going up, they're increasing. Our common difference would be 101, so they're going up by 101 each time. So the next number would be 404, and then 505, 606, and then 707. And there you go. Okay? So you're basically doing the same thing for these next two examples. So the directions say you're trying to find the first 5 terms of each arithmetic sequence that's being described. So all we want is the first 5 terms, right? You have the first term. They tell you a sub 1 is 101. And how you're going to get to the next term, they also give you the common difference. So we just need 4 more terms after the first one. Again, we only need the first 5 terms, and the first one given to us constitutes as being one of those 5. So we just need 4 more. So how we're going to get to the next one, we're just going to simply add 9. The common difference is positive 9, so then I'd have 110 when I add 9 to 101. Adding 9 would be 119. Adding 9 is 128. Adding 9 is 137. And that's 1, 2, 3, 4. That's all 5 terms, so we're all good. So same thing for number 8. We have 210 is the first term. Find 4 more terms, just keep adding 40. So you'd have 250, 290, 330, and then the last one would be 370. So again, that's 1, 2, 3, 4, 5 terms. So we're all set. All right, so for the next problems, it says to find the indicated term of each arithmetic sequence. So here's how you kind of read this. The first term in the sequence is 4. We're adding 6 each time to get to the next term, and we're trying to find the 14th term. Okay, so you could honestly just start with 4 and then add 6 each time until you get to the 14th term. You could do that. But if I asked you to find like the 70th term, do you really want to write out all 70 numbers? Probably not. So that's why, again, we have that really cool formula to get us to the correct answer a little bit faster. So how you kind of plug it all in, I'll write it here too, just so we don't have to keep scrolling up and down. Okay, and glancing up and down, but we're just going to plug it all into there. So what we're trying to find again, we want to find the 14th term, a sub 14. We know the first term is 4. Plus sign comes next, and then n minus 1 times d. Just plug it all in basically where it goes. That's it. So now just do your calculations, use your order of operations, doing your PEMDAS. So first, parentheses, that's 13. And then this would be 4 plus, so now multiplying, 13 times 6 should be 78. And then we just need to add these two together. 82 would be the 14th term in the sequence. Okay, so same thing for number 10. We're trying to find a sub 12. We know the first term's negative 4 plus 12 minus 1 times d. So it's all plugged in. Now just evaluate. So 12 minus 1 is 11. Now multiplying. That'd be negative 22. And now just simply adding, the 12th term should be negative 26. Okay, the next one, plugging this all in. So we're trying to find the 21st term. First term's 80. 21 minus 1 times d, which is negative 8. So it's all plugged in. So you'd have 80 plus, that'd just be 20. Now multiplying. So that would be negative 160. And now adding these two together, negative 80 will be the 21st term in this sequence. And the last one, we're trying to find the 25th term. First term's 15. We got 25 minus 1 times negative 1. So this would be 15 plus. That'd be 24 times negative 1. So 15 plus negative 24. And this comes out to be negative 9. Okay. So now you've at least seen how the formula works, which we're still going to be using that formula even on the back page. So as we turn the page to the back side, little story problem here. So let's just kind of pretend it says a table shows typical costs for a construction company to rent a crane for 1, 2, 3, or 4 months. So here is the table they're talking about. So let's just pretend we have a project, right? We own our own construction company and we have to rent a crane from somebody. So for 1 month, it's $75,000. 2 months to rent the crane, $90,000. 3 months, $105,000. 4 months is $120,000. So assuming that this sequence continues, we want to know how much will it cost us then to rent it for 12 months for a full year. Okay, so basically if you just kept on going in this table all the way up to 12, well, what's the cost going to be? Okay, So let's label what we know. So looking at the table, we can see these numbers are going up, and they're going up by 15,000 each time. So that's going to be D, the common difference. We're adding 15,000 each time. We obviously see the first term of the sequence. So that's A sub 1, 75,000. And the last thing we know is we're trying to find, again, month 12. What does that represent? Well, that would be N. We're trying to find in month 12, so going up to the 12th term, basically. That's what we're trying to figure out. So plugging this all in again into the formula, we're trying to find A sub 12, and that's equal to 75,000 plus N minus 1 times D. So doing this calculation, you should get $240,000. So if we had to rent this crane for a full year, it's $240,000. And then same thing for the next one. We want to know how much is it going to cost for 24 months now. So the only thing we're changing really is N. N's going to be 24. So we want to know A sub 24. Given again, A sub 1 is 75,000 plus 24 minus 1 times D is still 15,000. So doing this calculation, you should come out with $420,000. All right, so again, different way, different type of problem, using the same idea though. So it's a little bit tougher sometimes to identify, what you're trying to find and what do I know, but that's just the hardest part. Okay, using the formula is pretty easy, but just figuring out what exactly is what, where can I plug it into, that's the hardest part. So for the next one, it says that we want to write an equation for the nth term of each arithmetic sequence. So our objective is this right here. So your answer is actually going to be an equation. You need to write an equation for the nth term of each sequence. So you're writing down an equation that you can use to find any term of this sequence. So again, just label what you know so far. Just by looking at number 14, what can we actually label? Well, we could see the first term, A sub 1. The first term is 8. We can also figure out the common difference. What are we doing to get to each number? Well, we're adding 9. So D would be positive 9. Okay, and that's honestly all that we know. We know nothing else about this problem. We don't know the last term of the sequence. We don't know how many terms there are altogether. This is it, because it goes on past 35. You see that dot, dot, dot. That means it's just going on to infinity. Okay, never ends. So now, using these two items, again, plug these into the formula so far. So once again, here's the formula. So we only know this thing and we know this thing. That's it. We know A sub 1, we know D. So plug those two in where they go. So to find any term in this sequence, that's going to be equal to 8 plus, we don't know N, but we do know D is 9. Okay, now just simplify this as much as you can. You can do a little bit of simplifying. You can distribute this 9, do a little backwards distribution. So that'd be 9n minus 9. And now just clean it up, combine your like terms to find any term to the sequence. This would be your equation, 9n minus 1. So just combining 8 minus 9, negative 1. So same thing for 15. We can obviously see the first term. We can figure out what D is. Numbers are going up by 25 in this case. So again, plug those two values in where they go. So to find any term, we're doing negative 10 or negative 110 plus n minus 1 times D. Again, little backwards distribution. So that'd be 25n minus 25. So now completing this equation, this would just be to find any term to this one, it'd be 25n minus 135. And there's your equation. Okay. Next one, we'll just kind of do one more for practice, but again, we could see the first term, that's A sub 1, figure out what's going on here, and it looks like you're increasing by 1.9. So that would be D. D would be positive 1.9. So now from here, plug these two values in again to find any term. You're doing, it'd be 6.2 plus n minus 1 times 1.9 times D. So again, distribute 1.9 to both terms. So that's 6.2 plus 1.9n minus 1.9, and now just combine your two like terms. So this equation would be 1.9n, and then 6.2 minus 1.9 should be 4.3. And there's your equation. Okay. Arithmetic means, the last part here, you're just basically trying to fill in these blanks. All right, so we want to know those missing terms of the sequence. So once again, Label what you know. Just by looking at problem 18, what can we actually label? We see the first term, there's a sub 1, and we see the last term. Okay, we know that for sure. We got the first term, we got the last term, so it stops at -3. This sequence does not go on past -3. There's no dot, dot, dot after it. So we got the first term, we got the last term. We should also know how many terms are in this sequence. So if you count it out, 1, 2, 3, 4, 5 terms in the sequence. What we don't know is how we're getting to the next term. Right? If we did, then we would just do it right now, but we don't know how are we getting to the next term after 5. Okay, so again, plug it into the formula, and then we're going to be solving this for D. So you'd have -3 equals 5 plus n minus 1 times D. So now I'm just solving for D. So it'd be -3 equals 5 plus 4D. Solving for D, subtracting 5 is -8. Dividing by 4, all we have to do is subtract 2. So D comes out to be -2. I need to subtract 2 to each number to fill in those empty blanks. So 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is -1, and then -1 minus 2 should be -3. Okay, the next one, number 19. Again, we can see the first term. We see the last term. And again, there's only 5 terms to the sequence. So we got everything labeled. Now again, we're just solving for D. How are we getting to the next term after 18? So you'd have -2 equals 18 plus 5 minus 1 times D. So -2 equals 18 plus 4D. Subtracting 18 is -20 equals 4D. And then dividing by 4, we just need to subtract 5. So D is -5, just keep subtracting 5 to each number. So that would make this 13, 8, 3, and 3 minus 5, luckily, is -2. Okay, so 20, same idea. We got a sub 1. We got a sub n. How many terms this time? There's 4 blanks and then 2 additional numbers. So that would make that 6 altogether. So we'd have 48 equals 108 plus 6 minus 1 times D. So going through, solving for D, we'd have 48 equals 108 plus 5D. If I subtract 108, that's -60. Dividing by 5, you should get -12 for D. So just keep subtracting 12. So from 108, if I subtract 12, that's 96. Minus 12 is 84. Minus 12 is 72. Minus 12 is 60. And then minus 12 would be 48. Okay, we'll just do one more. Let's just try 21. Again, we see the first term, we see the last term. This one only has 4 terms altogether, so plugging this all into our formula, 235 equals 100 plus 4 minus 1D. So 235 equals 100 plus 3D. Subtracting 100 is 135, and then dividing by 3, and this should come out to be 45 in the end. Is D. So we have to increase by 45. D is positive, so you want to keep adding 45 to each term. So this would just be 145, 190, and then adding 45 more is 235. Okay? So there's your first lesson. We'll be moving on to series next. So let us know if you have any questions, and have a great day.